nerve is leading the eye. This is your blind spot. So you're driving down the street, and all of a sudden that ball just kind of flies past your windshield, and you slam on the brakes. You're thinking, well, why didn't I see that ball before? It's because the image was actually in the blind spot. Once the image was out of the blind spot, then it was focused on your retina. So in order to see it, it has to be focused on the retina. If the image is coming in and it's going directly in your blind spot, you can't see it. Okay? So what we're going to do is we're going to test the blind spot. So you take 5 objects, I think it says 5 coins, and you put them in a straight line. Okay? You have to be a much further distance apart. I'll say where the middle of the aisle is. And what you're going to do is you're going to close your eyes, and you're going to hold the card over your eyes, and you're going to focus on the center one. Okay? When you focus on the center one, the ones in the periphery are in your blind spot, and they're going to disappear. Okay? Now, if I move my eye just a little bit to look at that, okay, now that image focuses on my retina, and I can see it. So if you focus, once again, if it focuses here in your blind spot, you can't see it. But if the image comes in and focuses on your retina, remember the retina is here and here, if it focuses on your retina, it's visible.
Is that why when you take your driving test, they always tell you to check your blind spot?
Say it again. Exactly, and that's why you have to turn your head.
I remember like when I took my driving test for the first time, I would never turn my head.
Right.
And like, I remember I almost hit somebody.
Absolutely.
Because I didn't like check my blind.
Right. Because what you're doing is when you're turning your head, you're taking the image from here and you're moving it onto your retina. Okay, so you can see it. All right. Light reflex. So we're going to look at the diameter under normal light. Now remember, if a person is in sympathetic mode, their pupils are going to be, yes, dilated. So pupils are going to be dilated. Now when you are in dim light, what happens is that your pupils should constrict like this. I'm sorry. When you're in bright light, your pupils should constrict. So if I shine the light in the eye, because what I'm doing is, if we use this imaging, I'm shining it here and I'm shining it on the retina, okay? Those photoreceptors. The photoreceptors is basically saying that's too much light and it causes your pupil to constrict. So when you shine the light on the eye, like this, okay, it should constrict and get smaller, like that. But if someone is in sympathetic mode, and you shine the light on their eye, you're not going to get that response. Okay? It's going to stay large. So even though the person is not saying anything, maybe they were knocked unconscious, and you see people open their eye and they shine the light in their eye, they're trying to see if they're in sympathetic mode. Is this pupil going to respond? If they're brain dead, the pupil is also not going to respond. Right? Any questions about that?
My friend's an O&M therapist, O&M occupational motor therapist. You know, they're talking to blind people.
Oh, right,
And there's one of her kids, she's blind. Is it because she's blind and there's no response? Like when you shine a light, there's absolutely no response at all?
Exactly.
So it's basically just like
Exactly. Because remember that pathway, the pathway from here all the way to the signal node somewhere is in here. Okay.
So it's going to be...
So it's not responding because the brain is not picking it up. So if the brain's not picking it up, the brain's not going to respond. You're not going to tell the eyes what to do. Does that make sense?
Yeah.
Yeah. Okay. All right. So the hearing test, the I use this tuning fork for several reasons, several different things in office. One reason, one way that I use it is that if a person has, say for instance, they come in with a broken finger, and I didn't have an X-ray machine in my office, they actually have to go across the street. But if I wanted to confirm that their finger was broken, what I would do is take this tuning fork and strike it, and place it on that finger. So if their bones were broken into little pieces, and I do this, what's going to happen is that the vibration is going to move from the tuning fork down into the finger, because the little bones are going to start to vibrate, and that's going to be very painful. So unless we know your finger's broken, okay, even before I send them over for an X-ray. Right? But we're going to use the tuning fork for hearing test. Right? So your middle ear deafness, you're going to locate the person's master process, which is here, and you're going to strike the tuning fork. And then you're going to put it on the mastoid process. The vibration is going to move inside the ear, and it's going to stimulate that vestibulocochlear nerve. So you're going to count 1, 2, 3, 4, until they can't hear it. The tuning fork is still vibrating. Then you're going to take that vibrating tuning fork, and you're going to place it here and ask them, can they hear it? And you're going to start over counting. 1, 2, 3, 4, 5. So this is bone conduction. This is air conduction. So bone conduction basically means that the mastoid bone is vibrating. That vibration is going to go and vibrate the ossicles, okay, which is going to eventually cause the inner ear fluid to move, and the nerve is going to be stimulated. So if I put it on the mastoid process here, so what happens is the vibration is going to move the bones, move the ossicles, move the fluid, and it's going to stimulate the nerve. Okay? That's bone conduction. When it's still vibrating, and I switch it from here to here, now the vibration, okay, the waves are going to move into the ear and eventually stimulate the nerve. Right? So what happens is, this is bone conduction, this is air conduction. Air conduction should be twice as long as bone. Write that down. Air conduction should be twice as long as bone. And then the Weber test, you're going to strike the tuning fork, and you're going to place the vibrating tuning fork in the forehead like this, and what you want to make sure is that they can actually hear it bilaterally. They can hear it equally in both ears, and they should. If an ear is stopped up, then the sound is going to be magnified in the opposite ear. Right? Any questions about that?
Or since the air conduction has to be twice as long as the bone conduction, what if they're about the same? What does that mean?
What's about
If
the
they're about the same
This
time,
air conduction usually should be a little bit longer.
but if it's not,
Then it's probably something wrong with the nerve. Because remember, those hair cells, once they're damaged, you can't replace it. So hair cells may have been damaged by loud music or explosion, scuba diving, that kind of thing. Any questions? We have 3 slides. We have the pineal gland, we have the thyroid gland, and we also have, should have the thymus. I'm sorry, we have pineal, we have thyroid, and we have adrenal.
That's for lab 8.
For lab 8.
We're looking at it at a 40.
Say it again.
I was looking at it at a 40.
Oh, the magnetic tenets. Yeah, I read it before. Don't forget your ear is here. Okay, so what you need to know on your ear, eustachian tube is here. This is the one that connects to the middle ear. The outer ear is here, middle, and inner ear. Inner ear is the only one that has fluid. The cochlea is here. Semicircular canals is here. Right? And then your ossicles, you can see that. Yeah, the bones are right there. So make sure you take a look at this or take a picture of it. And then your eye, which is here. One of the questions that I will ask you about the eye is if you're looking at the right and the left eye. And how do you know that is because the lacrimal gland is always on the lateral side. So this is going to be your right eye because the lacrimal gland is on the lateral side. This is your tear gland. So remember, when your lacrimal gland contracts, it's going to wipe your eye or clean your eye from lateral to medial, and then the tears are going to drain out of your nose. So note the structures of the eye. Retina